So we're on page 24, topic 7, and on page 23 in the previous video we went through the basic formulas for the equations of a straight line and finding the slope, the intercept, and we discussed parallel and perpendicular lines. So now we're going to do some examples, and we're going to look at the slope of the line examples. So here we're going to look here, the slope of the line, and we're going to look at problems A, B, C, and D, and we're going to analyze them, and we're going to look at lines that slope upwards, lines that slope downwards, lines where the slope is 0, and lines where the slope are undefined, and analyze each one of those. So let's go to problems A and B, and look at that. So first of all, we're going to look at the slope of the line that's through the 2 points here, and we're going to calculate M. So here's x1, y1, and here's x2, y2. It doesn't matter which we call x1, y1, or which we call x2, y2. We'll get the same answer. And there are 2 different ways here that are shown depending on which you're calling x1, y1, and x2, y2. If you call, in the first case, this is x2, y2, and this is x1, y1. So we have 5 minus 2 right here over 3 minus 1 right here, and the slope comes out to be 3/2. Now let's say we did the reverse, and we said 2 minus 5 right over here divided by the x values, 1 minus 3, we get minus 3 over minus 2, which still gives me 3/2. So it doesn't matter which one of these 2 we call x1, y1, and which we call x2, y2. Just don't mix them up. Just don't say mix up x1 and then pair it with y2, or pair y2 with x1. You must have the same ordered pairs together when you're doing this. So here you can see that the slope is positive, M is greater than 0, the line slopes upward. Okay, when we say M is greater than 0, we mean that the slope is positive. So when the slope is positive, the line is moving upwards. The slope is moving upwards. Now here, in this case, case B, again, it doesn't matter which one we use, but here we're taking this is your x2, your x2, y2, right here, x2, y2. So we're taking 5 minus 3, 5 minus 3. Of course, the minus gives us plus, so we have 5 plus 3. And the difference in x is minus 1 minus 3. So minus 1 minus 3. So we have 5 plus 3, which is 8, over minus 4, which is minus 2. Minus 2 is less than 0. So when the slope is less than 0, the line slopes downward, as it does here. Here the line is sloping downward, and here the line is sloping upward. That is differentiated by, in the case when the line is sloped upwards, the slope is positive. When the line slopes downward, M is negative. Minus 2 is a negative number. So we've covered lines that slope upward and lines that slope downward. Now let's get to some 2 special cases, which are horizontal and vertical lines, and let's look at their slope. So here we have, in this case, in C, we have a horizontal line. It's going along the horizon. Imagine the sun setting on the horizon. This is a horizontal line. whereas this line here is vertical. Now let's look at the difference in the slopes for a horizontal versus a vertical line. Okay, now we hear the y doesn't change here. The x changes, but the y doesn't change. So this is the slope of the line is, the equation of the line is y equal to 2 because the value of y does not change. So here we're saying the line has the equation y equal to 2. So when we do the slope of this, the y doesn't change and the x changes. And so the change in the x is 2 minus 1, which is 3. 2 plus 1 is 3. The minus here give me a plus. 2 plus 1 is 3. 0 over 3 is 0. So lines that are parallel to the x-axis have a slope of 0. This line here is parallel to the x-axis. It has the equation y equal to 2 because the y value doesn't change. Okay, now we go to this case where we have a vertical line, okay, and you'll notice that the x doesn't change here. So when we do the slope and we say minus 1, we're going to take this as y2 right here and this as y1. So we're going to say 1 minus 1. Okay, that's my difference in the y's. Here's my y2, here's my y1. y2 minus y1 over x2 minus x1. That doesn't change because the x values don't change. So I have, there should be a little equal sign here. 1 plus 1 over 0. I have 2 over 0, which is undefined. We can't define how many times 0 goes into 2. It'll obviously go in an infinite number of times. So let's go over that again. We have horizontal lines right here. When we have a horizontal line, it's defined as x equal to 2. The slope is 0. Okay, or we can change this number. In this case, it's y equal to 2, but this number, if it was running through y equal to 3, it would still be the same. The horizontal line would still have a slope equal to 0. They were just chosen the number 2 randomly here. Now in this case, we've chosen x equal to 2. And in this case, the equation of the line is x equal to 2 because no matter what the value of y, no matter what the value of that y along this line here, x always equals 2. Here we have, let's say, y equal to 3, y equal to 2, y equal to 0, and x will always be 2 along here. So no matter what the value of y, we can change the value of y, but the x doesn't change. So when we do the slope, the denominator becomes 0. Whenever the denominator is 0, the number is undefined. So to summarize, horizontal lines, slope is 0. Vertical lines, the slope is undefined. Horizontal lines have the form y equal to some number. Vertical lines have the formula x equals some number. Okay, so let's look at these problems. We have 3 problems. We're on page 25, topic 7, and we have 3 problems, 2, 3, and 4. We're going to look at these problems and look at them in more detail and explain what is happening. So let's look at problem example 2, and we're on page 27. Find the equation of the line with a slope of 5 through the point 2, 7. So one way we can do this, or we can do it two ways. We can use either the slope-intercept form, or we can do it with a point-slope form. So we can do it with either. We can do it with a point-slope form, or we can do it with a slope-intercept form, and we're going to see that we get the same equation. Now, what do we know? We know that the slope is 5, and we know that the line goes through the point 2, 7. So, first of all, since we know if we use the slope-intercept form, which is this one right here, remember there are two basic equations we can use, the slope-intercept form or the point-slope form. We're going to see that no matter which of these two equations we use, we get the same answer. So we know the slope is 5, so we replace m with 5, and we get y equals 5x plus b. Now we know that the line goes through the point 2, 7, so we know when x is 2, y is 7. So we replace the y with the 7, and we replace the x with the 2, and we can calculate b. So 7 equals 10 plus b, and b equals 7 minus 10, because we transpose this from the right side to left and change the sign, so b is equal to minus 3. So y equals mx plus b. M we know is 5, and we've just calculated b as being minus 3. So the equation of the line is y equals 5x minus 3. Now, as I said, in this particular case, we can also use the point slope form. So we know the point, we know that it goes through 2, 7. So we're going to place y with 7 and x with 2 in the basic equation. And we know that m is 5 because we were given it in the problem. So we start off with this equation. We put the slope in right here. We put the ordered pair to 7 because we were given it. There's the y value. There's the x value. And we get y minus 7 equals 5x, 5 bracket x minus 2. So what we've done is we've used the distributive rule here. 5 times x gives us 5x. 5 times minus 2 gives us minus 10. And then we've transposed the minus 7 from the left to the right. Minus 10 plus 7 gives us y equals 5x minus 3. The minus 10 plus the 7 gives us minus 3. So the basic equation is 5x minus 3, which is identical to what we got over here. Note that we get the same equation no matter which formula we use, whether we use the point slope form or here is the slope intercept form, and the point slope form is right here. So it doesn't matter which of these two we use, we get the same answer. Now let's go to the next problem, number 3. Find the slope of the line with the equation 2x plus 3y equals 4. So what we want is m, and m equals mx plus b, but this equation is not in the form mx plus b. So we have to transform it into that. So what we do is we move the 2x from the left side to the right side, and that's why it becomes this, minus 2x. So we've moved the 2x to this side, and we get minus 2x. The 4 is still there on the right side. Now we divide by 3. We get y. We divide the minus 2x by 3, and we get minus 2/3 x. Plus, When we divide the 4 by the 3, we get that. So the slope is always the number in front of the x when the equation has the form y equals mx plus b. So the coefficient is the number in front of that, in front of the x. So we know the slope is minus 2/3. Now, here there's a little note which I'm going to explain in more detail. If we have an equation in the form ax plus by equals c, this is another form of the equation. You may occasionally see it. And if we see it in this form, the slope of the line is minus a over b. In other words, whatever the coefficient of x is, we put it over here. Whatever the coefficient of y is, b, we put it over here, and then we put a negative on it. Now, how do I get the value that minus a over b is the slope from this equation? So here's how I do it. First of all, I start with ax plus by equals c. Now, I'm going to isolate the by term. That's this term on the left side. So I'm going to move the ax to the right side, and I get by on the left, which it is here. I move this over to the other side, I get minus ax plus c. Now I divide each term by b. So I divide this by b, minus ax over b gives me this, and I divide the c term by b. And you say, well, why do you do that? Because I want the equation in the form y equals mx plus little b. It's little b. Little b is equal to c over b, but we're not concerned with that here. Here's what we're concerned with. This number in front of the x is m. M is the coefficient of x and equals minus a over b. So all we're doing is going back to the basics that we want the equation in the form y equals mx plus b. When we write it like this, it's not in the right form. We transform it into so that y is alone here. And then whatever appears in front of the x must be m. So m is the coefficient of x and equals minus a over b. So if we have the equation 2x plus 3y equals 4, a equals 2 and b equals 3. A is the coefficient of x, b is the coefficient of y, m equals minus a over b, so minus 2 over 3. Let me make this clear here. This should read that m equals minus a over b, and m is the coefficient of x. Now, as our final problem here, we're going to do find the equation of the line through the point 1,8 that is parallel to the line y equals 2x minus 5. Now, the fact that we know that this has a slope of 2, and we want the equation of the line through the point 1,8, but that's parallel to this, we now know the slope of the line we're looking for is 2. So the equation must be y equals 2x plus b. We're looking for a point that goes through 1,8 and that is parallel to this. Well, if it's parallel to this, it must have the same slope. So we write y equals 2x plus b. Now, we know that it goes through the point 1,8. So what we can do is put y equals 8 and x equals 1 into the equation y equals 2x plus b. Because we don't know what b is. We have to compute b. But we do know that the line goes through the point 1, 8. So we replace y with 8. That's this value right here. And we replace x with 1 right here. And when we do that, 8 equals 2 plus b. So b equals 6. So here's the line that we're looking for. This is the line, 2x plus 6, is parallel to this line and goes through this point right here, 1, 8. Now, how can I verify this? Well, if this is the right line, I'm going to substitute x equal to 1, which is this number here. And when I do, I get y equals 2 times 1 because I'm replacing the x with a 1, plus 6 gives me 8. So when x equals 1, y equals 8. This verifies that the point 1, 8 lies on the line y equals 2x plus 6. So let's go over this again. We want the equation of the line through the point 1, 8. That is parallel to this. So we start off with the equation y equals 2x plus b. Because it has the same slope, we just put a 2 here, mx plus b. But we don't know b. We calculate b by putting this ordered pair in, 1, 8, that we are given. And when we do that, b comes out to 6. So we know that the equation of the line we're looking for is 2x plus 6. We check the answer by substituting x equal 1 and y equals 2 times 1 plus 6, and therefore y equals 8, which it should be. If we didn't have the right equation here, if for some reason or another we didn't have the right equation, then the point would not show to be on the line.